One is, you can say, point of inversion I, and second one is alternate axis. Okay, after that, then we move to the molecular point group. So I think there is no any problem in this visibility of screen as well as I am audible completely, so no problem. Now say, which elements we have completed in last two lectures? First one is,
सर सर
yes,
सर रिकॉर्ड भेज देंगे
sure, आपको मिल जाएगा. Which two lectures we have, see, which two in the last two lectures, which are the symmetry elements that we have already completed? Can you have any idea? Is there anyone?
Sir. Yes, sir.
Yes.
Sir,
First one is,
for all the three plane of symmetries, sir, the three types of symmetry, plane of symmetry we have discussed, sir, horizontal, vertical, and diagonal, and few examples also we have covered.
yes, and we have covered certain examples related to that plane of symmetry, and also we have completed proper rotation axis. We have already completed identity E. So these are the symmetry element we have already completed. Now, what is the center of inversion or point of inversion I? So see, it is a point from which on opposite side at equal distance, equal number of atoms are present. This is nothing but a point from which on opposite side at equal distance, equal number of atoms are present. A center in a molecules that has the same atoms at equal distance, but in a which direction? This is very, very important, in opposite direction. So you can say that that molecule having center of symmetry I. See, if you are applying I, so you are getting totally inverse, same result but with opposite side. That is we call center of inversion I. Suppose in this molecule I want to take a center of inversion I here. I want to do this point of inversion I process. Then what should be the change which is taking place? Which two atoms can change their position? A and B can change their position, and 1 and 2 can change their position in this way. See, look at here. 1 and 2, they are in opposite direction. So they can change their position at the same times. A and B can change their position. So this is called, we have applied point of inversion I process. And condition से है आपको either same structure मिलना चाहिए या तो equivalent structure मिलना चाहिए. Okay, so this is we call molecule having point of inversion I. Now, is this molecule having point of inversion I? Suppose I will take here Cl, here also Cl, and here 2 hydrogen. Can we take center of inversion I in this molecule?
No.
No. Why?
No. Because hydrogen are cis and chlorine are cis to each other, so we cannot join the opposite point.
Yes, we cannot join the opposite point, or equal number of atoms are of course present at same distance. See, at same distance, equal number of atoms are present, but these are not there in opposite direction. And that's why say I is absence. Definition of I is equal number of atoms must be required at equal distance on opposite direction. This is very, very important. If you having, suppose this molecule trans geometry, then you should definitely have a point of inversion I. You can take I here in the center. So at whatever distance H is there on opposite direction, at same distance hydrogen is there. So this H1 and H2 can change their position. Cl1 and Cl2 can change their position. Carbon 1 and carbon 2 can change their position. If you apply I, you can do process that is called point of inversion I. So here it is C1 and here it is C2. Cl1 is replaced by Cl2 and here it is Cl1. Similar, H1 and H2 can change their position. Here it is H2 and here it is H1. So this is called, you have applied symmetry element I, or you have do the process of I. Now see, look at here, in this case molecular formula is H2Cl2 C2. So if all the atoms are even, then I is present on. At that time, see, I must be present on, you can say, I must be present in between atom. I is present in between atom. And if one of the atom is odd, then I is present on odd atom. See, this is also a symmetrical molecule. Where is I? I is on
Carbon.
carbon atom. Good. Because at whatever distance here oxygen is there, on opposite direction at same distance oxygen is there. So therefore I is present on odd atom. If one of the atom is odd, then I is definitely present on that odd atom. So this is called point of inversion I. See, in SF6 there is a I. Center of inversion I is over here. So 2 and 4 are at opposite equal distance in opposite direction. 1 and 6 are in opposite direction. 3 and 5 are in opposite direction. So if you apply I, then 2 and 4 can change their position. At the same time, 3 and 5 can change their position. And 6 and 1 can change their position. Okay, so in this way, at opposite direction at equal distance, equal number of atoms are there. If you do again I process, then you are getting original structure. So in short, say I square is equal to E, identity. If you do 2 times I process, then you are getting original structure. Even you can do 4 times, 6 times, okay, in even numbers, then you are getting original structure. So this is the case of the geometry which is octahedral SF6. Now see in the staggered conformation of ethane, see this is a staggered ethane. One carbon is on back side, another is on front side. Here also see I is there. Where is I? How to getting result of I operation? See this is called front carbon, where 3 hydrogens are there.
So middle to bond, carbon bond, middle.
Yes, in between 2 carbon atoms, or it is called between carbon bond. So here it is H5, and you can have a H6, H4 and H6. So you can take a point of inversion I here. So H1 and H5 can change their position. 3 and 5 and 2 and 6 can change their position. So definitely see if you apply I over here between 2 carbon atom. So 1 and B can change their position. C and 2 can change their position, and 3 and A can change their position in this way. Similar, if you apply again I, this is a one time I process. You can go for second time I operation. See in this way, red color, all the hydrogens are, or green carbon is comes on it at the place of pink carbon, and pink carbon is goes to place of green carbon. Or green carbon is a front carbon which is goes on back side, and back side carbon, that is pink carbon, is coming on front side. So this is called I. But methane does not have a I. See, look at here. This is a tetrahedral geometry. Pink color hydrogen is on our side. So if you are applying I, then it is goes on back side, which is not an equivalent structure. Look at here. These two structures are different. So you can say that in a methane or in a tetrahedral shape, I is absent. I cannot be there because you are getting different position, and therefore I is not there. Okay, if it is different position, then I may not be there. On the now last symmetry element is a improper rotation of axis. What is the difference between say proper and improper? So whatever the C and axis we have seen, it is a proper rotation, and improper means it is not a direct rotation. Generally what happens is, suppose you are having ABC, so if you do its rotation about any axis or about this axis, then order cannot be changed. Here order is A is see, A is followed by B, B is followed by C. In this is in order. This particular order is there. So if you give rotation, then that order is maintained. See, this order cannot be changed. A followed by B followed by C. This is in order. So this is called say proper rotation. But in the improper rotation, what happens? In improper rotation, this order gets. Or it is also called rotation reflection axis. Am I audible?
Yes, sir. Audible.
Okay, fine. Good. So see, this is called alternate axis, or you can say rotation reflection axis, or it is improper rotation axis. All they are the phenomenons. It is SN, represented by SN. So here see two processes take place, and after that two process, then you will going to check whether you are getting equivalent position or not. First process is a rotation, and second process is a reflection. First, you give a rotation at particular angle, whatever you have given in proper rotation axis. After that, then you can go for a reflection. Reflection using plane which is perpendicular to rotation axis. So if you are getting same structure, then you can say it is that molecule having improper rotation axis. And if you are not getting equivalent structure, then we can say that improper rotation axis or alternate rotation axis is absent. So improper rotation may be thought of a two-step process, that is rotation and reflection in a plane perpendicular to rotation axis. So now let me check one example. See, this is a tetrahedral geometry. You know that, see, here four different atoms are there. This, you can say, two hydrogen is which are on our side and other two hydrogen are on, one is on right side. See, this is on right side to you, this is on left side, and this hydrogen is on front side, and this is on back side. Now what you can do, you can give see rotation about this axis from middle, that is rotation about at C4 axis, that is called rotation at angle 90 degree. C4 means rotation is given at 90 degree. So right now what happens, see, right side and left hand side hydrogen are there in plane of your mobile, and front hydrogen and back side hydrogen which are out of plane. ये वाला हाइड्रोजन है वो आपकी साइड है, सी यहाँ पे है वो फ्रंट वाला, बैक साइड वाला हाइड्रोजन है वो पीछे की साइड रहेगा मोबाइल की बैक साइड, एंड right side and left side hydrogen are in the plane of mobile. Now if you give rotation to this molecule at 90 degree, what happens? If you apply rotation at 90 degree, then those hydrogen which are in the plane, they come to out of plane, and those hydrogen which are out of plane, they enter into plane. 90 डिग्री पे रोटेशन दे रहा है, ये फ्रंट वाला हाइड्रोजन जो आपकी साइड है वो प्लेन में चला जाएगा, आप रोटेशन देंगे तो, और वह भी सी आप एंटी क्लॉकवाइज रोटेशन देंगे 90 पे, तो ये हाइड्रोजन जो फ्रंट वाला है वो आपकी राइट साइड यहाँ पे आ जाएगा, एंड जो बैक साइड वाला हाइड्रोजन है वो आपकी लेफ्ट साइड यहाँ पे आ जाएगा. I just mark that hydrogen with a proper color so you can recognize it easily. See, this is a yellow color hydrogen. which are already there on front side, which is now coming to here on back side, sorry, on right hand side in the plane. And you can have this blue color hydrogen which is on back side. Now this has come to left side. Look at here. And those hydrogen which are already there on right hand side, you have given say anti-clockwise rotation at 90 degree. So this is a purple color hydrogen which are there on right hand side. So now it is goes to on back side. And remaining hydrogen, that is, you can say it's a green color which is already there on left hand side. Now it is coming to front side here. Now you can compare these two structures. So these structures are equivalent or non-equivalent? Yes. Yes, so C4 axis is absent in this molecule. These two structures are non-equivalent. You have just applied C rotation at 90 degree. That is, you have only applied C4 axis and they are non-equivalent. But see, in order to having S4 axis, so S4 it is a combination of two processes, that is rotation followed by reflection. So now rotation you have already given. Now you go for reflection. Reflection using plane which is perpendicular to principal axis, that is this red color plane. So this green and pink color hydrogen shows above the plane in this way. So this is a green color and you can say purple color. So now what happens in this case? Now you can say that now these two structures are equivalent. See, yellow color is replaced by green color, but hydrogen is coming to position of hydrogen, or you can say that shape or whatever in the front side hydrogen is there where another front side hydrogen is comes. Back side hydrogen is there where another back side hydrogen is comes. Now you can see compare this both the structure. Here it's a purple color, sorry. If you go for mirror image, if you are applying the plane, then it's purple color, and here blue color, and here it's a blue color hydrogen, and on your left hand side it's a yellow color. So see, that's why now you can compare structure number 1 and 3. So they are similar, they are equivalent. See, they are equivalent. Now compare 1 with 3. So this entire process where two processes you have carried out, first one is rotation about particular plane followed by reflection. So this is rotation, reflection is called this
Sir,
combined
हम
process
इसे
is
दिखा सकते हैं
क्या?
sir that this particular axis is called improper in the figure.
यस, ये वाली है ना जो यहाँ ड्रॉ करके बताइए, C4 एक्सिस जो है ना, this C4, look at this, it is nothing but S4. See, this is
सर
S4.
वो तो प्रिंसिपल एक्सेस हुआ ना.
प्रिंसिपल नहीं है इसमें, C4 कहाँ पे है? नॉन इक्विवेलेंट स्ट्रक्चर मिल रहा है आपको.
यस सर, यस
इसमें प्रिंसिपल एक्सिस C3 है. प्रिंसिपल एक्सिस कौन सी है? C3 है. कोई भी एक हाइड्रोजन में से पास कर लो तो दूसरे तीन अपने पोजीशन टेट्राहेड्रली चेंज करेंगे. एमोनिया की तरह है. सो 4C3 एक्सिस है इसमें.
ओके सर.
या C4 एक्चुअली C4 नहीं है, बट मैंने यहाँ C4 इसलिए लिया है. आई हैव इमेजिन दैट C4 एक्सिस गिवन रोटेशन एट 90, तो इक्विवेलेंट तो स्ट्रक्चर नहीं मिल रहा है, बट ये हाफ प्रोसेस हुई. अल्टीमेटली हम S4 प्रोसेस कर रहे हैं. S4 मींस दो प्रोसेस कंबाइन करोगे तभी ये कंप्लीट प्रोसेस होगी. फर्स्ट आपको रोटेशन करना है, उसके बाद रिफ्लेक्शन लेना है अबाउट प्लेन विच इज परपेंडिकुलर टू प्रिंसिपल एक्सिस, सॉरी रोटेशन एक्सिस. तो जो कुल मिला के आपको फाइनल स्ट्रक्चर मिलता है दो प्रोसेस करने के बाद, रोटेशन एंड रिफ्लेक्शन, तो वो स्ट्रक्चर अगर इक्विवेलेंट है इनिशियल स्ट्रक्चर से, सो यू कैन से दैट दिस प्रोसेस इज कॉल्ड S4. ऑल्टरनेट इसलिए बोला है, जो ऑर्डर है या सीक्वेंस है वो चेंज हो जाती है यहाँ पे, इसलिए. So see, this is called improper rotation, or you can say alternate axis, or you can say rotation reflection axis. And tetrahedral geometry is a very good example of this geometry. But see, suppose if you check, if you take a different atom, suppose you can take here 2 hydrogen and 2 Cl, then you cannot have a improper rotation axis. You cannot have a S4. इसमें क्या दिक्कत आ जाएगी बाद में, जैसे यहाँ पे आप ऐसे प्लेन रखोगे, सी इनिशियली क्लोरीन क्लोरीन की जगह जाएगा, हाइड्रोजन अपनी जगह हाइड्रोजन की जगह जाएगा, बट उसके बाद जैसे ही आप ऐसे रिफ्लेक्शन प्लेन कंसीडर करोगे तो दोनों क्लोरीन जो है उनकी मिरर इमेज हाइड्रोजन की पोजीशन पे मिलेगी. सो अल्टीमेटली हाइड्रोजन प्लेस ऑफ हाइड्रोजन इज ऑक्यूपाइड बाय क्लोरीन, सो यू कैन से दैट you are not getting equivalent structure, and that's why S4 is absent. इसलिए अगर आपके पास चारों लिगेंड सेम है और टेट्राहेड्रल ज्योमेट्री है, so it is a very good example of alternate axis. Now is it clear?
Yes, sir.
Okay, so up to here, see, we have completed all these 7 symmetry element. Rotation, proper rotation axis. See, this is called S4. This combined process is called S4. So now we have completed, see, identity. Second symmetry element is rotation axis Cn. It is again two type, Cn and Sn. Even in this CNC, you can have a two type rotation axis. You can have a two type. One is, you can say, principal axis, and another one is subsidiary axis. Principal axis is the highest pole axis passing through maximum number of atoms, and remaining all axes are called subsidiary axis. Now, after these two axes, then we are having, we have taken three types of plane of symmetry. That is called sigma H, plane which is perpendicular to principal axis, sigma V, that is plane which is parallel to principal axis, and sigma D, that is called diagonal plane. And then we have last taken point of inversion I. So there are 7 symmetry elements. Now see, in this molecule, you can have a S2. S2 axis is this. This is the case of trans geometry with two, suppose Cl atom and two hydrogen is there. You can take such geometry. So what you can do, first you can go for, if you want to see here S2, means you can do plus C2 process. That means rotation is given at 180. So what happens? Cl come to position of this, is you can take this axis and give the rotation at 180. What happens?
Cl hydrogen will go to place Cl.
Yes, so you are not getting equivalent structure. See, these two structures are different. Here it's a Cl and here it's a hydrogen. Sorry. Okay, here it's a Cl and here you can also have a Cl at the place of hydrogen. And on this side you can have a here hydrogen and here hydrogen. So these two structures are not equivalent. Okay, so you can say that you are not getting same structure. But this is a half process, followed by you can go for reflection about plane which is perpendicular to principal axis. You can take this plane to carry out reflection. So hydrogen now coming to position of Cl. Here it's a Cl. Here it's a hydrogen and here it's a Cl again. So now you can compare first structure with the third one. So these two are equal, and therefore the entire process is, you can say, this is called S2 process. In this way, CS2 is the, look at here, rotation followed by reflection, so you can have a equivalent structure. S21, this is called S21. You can do, see, second time S2, so you are getting original structure. See, look at here. So you can say that S2 raised to 2 is equal to E. Is it okay?
Yes, sir.
Okay, S2 raised to 2 is equal to E. Now see, this is a tetrahedral geometry. Look at here, how this is C4 axis. You can give rotation at 90 degree. So see, this is a 1 and 2 are present at 180, but this angle is, this is a cubic box where all the angles are of 90 degree. So where is one after giving rotation from center of this box? Box has a 3 dimensional cubic box. उसको आप 90 डिग्री पे घुमाते हो तो वन कहाँ पे जाएगा? 2 की
Next
जगह
point,
आएगा या यहाँ पे नेक्स्ट पॉइंट पे?
right?
यस, गुड गुड, यहाँ पे आएगा आपका, फाइन. एंड 2 जो है वो यहाँ पे आ जाएगा. Similar way, see 4 is coming to here and 3 is coming to here. So you are getting this result. Or see, you can go for anti-clockwise rotation, definitely. So we want plus axis, C for plus. So for plus, we are using anti-clockwise rotation, and for minus, we are using clockwise rotation. So see, this is one come to here, and this 2 is coming to here. Same way, 3 is comes to here, and 4 is comes to here. Okay, then what you can do next? You can go for reflection using this plane. So now this 1 is reflected here. Here it's a 1, and 4 is reflected here in this way. So the 4 is reflected at the position of 1. Here there is no carbon. So now you can compare structure number 1 and 3. So both are equal. So this is called S4 process. You have applied one time this S4. What happens if you see simply what is logic? Here 4 number hydrogen is below the plane. You can just shift it at one place and write down on upper part. Suppose I want directly, I want to write down the second time process. Then what I can do, I can shift 4 number here and write down at below the plane here at position of 1. Similarly, 1 coming to here and write down it is over here at position of 3. So in this way, see, this is called second time S4. This one. Similarly, see this 2 come to here and it is written over here. So this is called second time. Now you can compare with 1 and 2. So they are different, first structure and this structure. So they are different. They are different structure. So this is called 2 times S4. Now, so how many times S4 is required in order to get the same structure? So this is the third time. And if you give fourth time, then you are getting similar structure. Now at fourth time 4 is goes to here and it is reflected it below the plane. So you are getting original structure. So what you can say that S4 raised to 4 is equal to E. Or you can say that this structure you are getting by giving rotation at about C2 axis only one time. So you are getting this third structure. So see, in this case, this is S4 S2 is equal to, if you direct give rotation at 180 to original structure, that is called C2 raised to 1. So C2 raised to 1 is equal to S4 raised to 2. Or you can say C2 raised to 2 is equal to S4 raised to 4 is equal to E. This is called identity E. Okay, so this is called alternate axis. Now suppose see if you're having hexane H1, H2 and H3. Here it's a H4, H5 and H6. Now if you want to carry out S3 process, what you can do first? You can do first
H1 to H3.
Yes, first you can do C3 rotation about C3 axis.
H1 to H3.
Yes. So you can have a here H1, H2 and H3. You can have a here H6, H4 and H5. Something problem in the pen. So look at here. H3, H4, H5 and H6. Now if you give CS3 process, then two process taking place together. First H1 come to position of H2 and H2 coming to position of H3 in this way. And then you can write down reflection about this plate. So this front carbon shows on back side. So here it is H3, here it is H1, and here H2. Similarly, see backside carbon is coming to front side. So here it is H4, H5, and here it's H6. Okay, is it clear? First. Okay. Now what happens if you go for second time rotation?
H5 to H4.
Yes. It is now next time you can have a H. You can write down here. See, here it is in the position of H3. There is H5. Here it's H6, H4, and here it's H2, H3, and H1. Now you can go for third time S3. So you are getting, see here H1. You are not getting equivalent structure after 3 times. See, here it is H6, H5, and H4. It's H4 and H5. Now see what is problem with this structure. If you compare one and that last structure, then right side carbon is shows on left hand side and left hand side carbon become on right hand side. So they are not equivalent. So you tell me how many such type of rotation are required in order to getting same structure? In order to getting original?
4.
So फोर्थ टाइम में क्या होगा H1 नीचे आ जाएगा ऐसे इक्विवेलेंट स्ट्रक्चर कहाँ मिलेगा H1 यहाँ पे आ जाएगा H2 यहाँ पे H3 यहाँ पे आ जाएगा H5 H6 and H4 फर्स्ट एंड ये दोनों तो सेम नहीं है so it required 6 time rotation. So this is a 5th time rotation. H1 यहाँ पे आ जाएगा H2 यहाँ ऊपर आ जाएगा यहाँ H3 यहाँ पे आ जाएगा H5 H6 H4 इसी तरह आप फर्दर जाओगे S3 सो आपको इक्विवेलेंट स्ट्रक्चर मिल जाएगा ओरिजिनल स्ट्रक्चर. One, two, three. H. What is the problem? Okay, so here it is H4. 4 goes to position of 5 and reflected here, so it is okay up to here. Then again 4 is at the top of the plane. Here it is H4, sorry, and here it is H5 and 6. Again you can give rotation, then it is H6, H4 and H5. Now further you can go for rotation, so it is H5 comes to here, H6 comes to here, and here it is H4, and then you can further give rotation, then here it is H4, sorry, H1 already there is, here it is H4, here it is H5 and H6. Now these two are equal, see, original structure and these are equal, so you can say that S3 raised to 6 is equal to E, or you can have a C3 raised to 3 is equal to E. C3 raised to 3 is equal to E, or you can have a S6 raised to S3 raised to 6 is equal to E. Now is it clear? Up to here it is okay?
Yes, sir.
Okay. So see, this is called alternate axis. Look at here, same thing is. This is the eclipse structure. 1 2 की जगह आएगा, 2 3 की
That
जगह.
will be very complicated of S3 to the power 6 to draw.
What you can say?
Sir, you have just drawn, sir, that S3 to the power 6 is equal to E.
Yes. वो फिर से रिपीट करूँ ना?
सर तो सर ये कॉम्प्लिकेटेड नहीं हो जाएगा?
नहीं, कहाँ पे कॉम्प्लिकेटेड है? इट इज वेरी इजी. आप ही बताओगे. देखो यहाँ पे हम उसको सोल्व करते हैं. चलो फर्स्ट टाइम S3 करना है तो 1 कहाँ पे जाएगा पहले वो बताओ. पहले
वन
C3
थ्री पे जाएगा.
नहीं,
वन
एंटी
1
क्लॉकवाइज
C पे
रोटेशन.
जाएगा सर.
एंटी क्लॉकवाइज रोटेशन करेंगे.
ओके, देन
टू
B
पे
पे.
जाएगा.
हाँ, पहले ऐसे करेंगे. सी 1 यहाँ पे 2 की जगह, 2 3 की जगह, 3 1 की जगह, और उसके बाद वो कार्बन कहाँ चला जाएगा? ब्लू
B
वाला
पे.
पीछे, और पीछे वाला जो है वो
यस
फ्रंट
सर.
साइड. सो सी दिस इज वन टाइम. सी लुक एट हियर. ये जैसे आपने रोटेशन बताया वो, एंड उसके बाद ये रिफ्लेक्शन, ये मिडिल वाला प्लेट. तो जो बैक साइड वाला है वो फ्रंट साइड आ जाएगा, फ्रंट साइड वाला बैक साइड, इसी तरह. दिस इज वन टाइम. सी सेकंड टाइम, लुक एट हियर. अभी कहा आपको ऐसे ही पता लग जाएगा. जो आपको रेड वाला कार्बन है, ग्रीन वाला, उसको पीछे की ओर ले जाना है, और जो ब्लू कलर वाला कार्बन है वो फ्रंट साइड आ जाएगा. और ये है उनकी जगह सी, और बी की जगह आ जाएगा ये इसी तरह से. ये पहले रोटेशन, उसके बाद रिफ्लेक्शन है पीछे. ओके, सो इट इज ए 2 टाइम प्रोसेस. अभी थर्ड टाइम करोगे तो क्या होगा इसमें? 1 2 3 4 have changed their position, and this is sigma plane. So this is called 3 times. अभी आप इसको इसके साथ कंपेयर करोगे तो यहाँ पर्पल कलर है आगे, यहाँ पे रेड कलर आगे है, तो दोनों इक्विवेलेंट नहीं है. दैट मीन्स 3 टाइम के आपको इक्विवेलेंट नहीं मिल रहा है. नाउ सी फोर्थ टाइम. दिस इज फोर्थ टाइम प्रोसेस. फिफ्थ टाइम. अभी देखो दोनों प्रोसेस साथ में कर रहे हैं. डायरेक्ट लिखना है इसमें से. 3 है वो ए की जगह आ जाएगा पीछे की साइड, 1 है वो बी की जगह पीछे की साइड, और 2 है वो सी की जगह पीछे की साइड, और सी है वो 1 की जगह आगे की साइड आ जाएगा इसी तरह. ओके, और जो पीछे ए है वो फ्रंट साइड आ जाएगा 2 की जगह इसी तरह. एंड 2 है, सॉरी बी है वो सी की जगह 3 की जगह पे जाएगा फ्रंट साइड यहाँ. Okay, so this is called S3 raised to 4. Now see what happen if you go for S3 raised to 5. डायरेक्ट लिख पाओ. चलो फिफ्थ टाइम करोगे तो क्या होगा? सॉरी 6 टाइम. 5 टाइम तो कंप्लीट हो गया. बी कहाँ पे जाएगा?
PC.
नहीं, पूरा
3 के
प्रोसेस
जगह पे जाएगा.
हाँ, 3 की जगह पे. गुड. पूरा प्रोसेस अभी बताओ. रोटेशन एंड रिफ्लेक्शन दोनों कुल मिला के. सी कहाँ पे जाएगा? सी
A.
1
की जगह. सी ये तो रोटेशन देखे तो ये की जगह जाएगा. उसके बाद रिफ्लेक्शन भी करना है. और ये कहाँ पे जाएगा?
2
यस, गुड. 2 कहाँ पे आएगा?
C
सी की जगह. 3 कहाँ पे?
A
ए. एंड 1 कहाँ पे जाएगा?
B.
B.
Yes. So this is the result. Look at here. So this is called 6 time. Now this is equal to original structure. You can compare with original, and therefore it is written S3 raised to 6 is equal to E. See, this is a staggered geometry. So if you go for first time, so first if you give rotation, then ABC can change their position. Similar, H1, H2 and H3 can change their position at angle of 120 in this way. तो आपको ये रिजल्ट मिलेगा. उसके बाद आपको रिफ्लेक्शन करना है. तो जो कार्बन पीछे है वो ऑफ कोर्स ये इक्विवेलेंट नहीं है स्ट्रक्चर. देखो, सॉरी इक्विवेलेंट ही है. हाइड्रोजन है तो इक्विवेलेंट है. दूसरा कोई एटम्स होता तो नॉन इक्विवेलेंट हो जाएगा. सो सी ये दिस प्रोसेस इज कॉल्ड वन टाइम S3. ये ऐसे प्रोसेस है. यहाँ पे दिस इज स्टैगर्ड ऐसे तरह. सॉरी दिस इज इक्लिप्स. in this way. तो ये 1 2 3 है. यहाँ पे 4 5 6 है. तो फर्स्ट यू गिव द रोटेशन So what happens if you give rotation at 120? तो यहाँ 1 की जगह 3 आ जाएगा, यहाँ पे 1, यहाँ 2, इसी तरह 4 है उनकी जगह 6, यहाँ पे 5 है उनकी जगह 4, and 6 is replaced by 5. And then if you take this plane, mirror plane, so you are getting this type of mirror image. Now you can compare this structure with first one. Is there these two are equivalent or they are non-equivalent? In this way, जो कार्बन फ्रंट साइड है वो बैक साइड चले जाएगा, बैक साइड है वो फ्रंट साइड. बट आप 6 टाइम रोटेशन देंगे तो डेफिनेटली इक्विवेलेंट स्ट्रक्चर मिलेगा. Look at this molecule so you can understand well this geometry. This is the rotation at angle 60. 60 पे क्या होगा, अभी S6 चेक कर रहे हैं. ये ज्योमेट्री ऐसे है, सी आपको 60 डिग्री पे रोटेशन देना है. इसी तरह 60 में स्लाइटली
1 to C.
या बिटवीन सी 120 पे रोटेशन है, बट इट इज 60 पे रोटेशन है. तो ये 1 जो है ना, ये एग्जैक्टली ऑलरेडी पीछे की साइड है, तो ये एक एग्जैक्ट पीछे आ जाएगी यहाँ पे. दिस एंगल इज ऑफ 60, दिस इज आल्सो ऑफ 60 एंड दिस इज आल्सो ऑफ 60. 2 यहाँ पे बी है उनके पीछे आ जाएगा, पीछे की साइड. और ये जो बी है, सॉरी 3 नंबर, तो 3 है वो सी के पीछे की साइड. इसी तरह तो 60 पे पहले रोटेशन ऐसे होगा, बट जो 1 जो है वो पीछे की साइड था, वो पीछे ही रहेगा, ब्लू कलर. 2 है पीछे की साइड, वो पीछे ही रहेगा, बट 60 डिग्री पे आपको रोटेशन देना है. तो दोनों स्ट्रक्चर है वो नॉन इक्विवेलेंट है. अभी इसी तरह ये है वो 2 की जगह आगे की साइड रहेगा यहाँ पे. बी जो है वो 3 की जगह आगे की साइड यहाँ पे रहेगा, फ्रंट साइड. और 3 है वो सी की जगह पे, सॉरी 3 है वो सी की जगह पे यहाँ, ओके, फ्रंट साइड रहेगा ऐसे. So see, this is called as C6 process. Now what is next? If you want to carry out S6, you can go for reflection. तो जो कार्बन आगे दिखाई देता है, that will be this carbon become reflected on back side, and जो back side वाला है, it is reflected on front side. So इसी तरह से the rear carbon become front and front carbon become rear. Now you can compare with 1. So these two are different. Of course they are different. See, 1 जो कार्बन पीछे है वो एक्चुअली ग्रीन कलर वाला जो कार्बन है वो फ्रंट साइड है. लुक एट हियर, दिस इज ए ग्रीन कलर. बट कार्बन की जगह कार्बन, इसलिए आप एक आइडेंटिकल स्ट्रक्चर ले सकते हो, अदरवाइज यहाँ पे पिंक कलर आ जाएगा. हाइड्रोजन की जगह हाइड्रोजन है, को बी की जगह 2 देखो. So you can say that this molecule having S6 axis, this is called S6 one time. You can go for S6 second time. This is called S6 second time. And S6 second time is nothing but equal to 1 time rotation about C3 axis in a anti-clockwise. That is called C3 raised to 1. So you can say that S6 raised to 2 is equal to C3 raised to 1. What is result of S6 raised to 6? Is equal to C3 raised to how many?
3.
3. Good. Is equal to what?
E.
E. Yes, you are getting identical structure. Okay, so these are the, this is, you can say, improper rotation axis. These are the all 7 symmetry element. Same thing is there, staggered conformation is there. Front side carbon is blue color and red color is a back side. So once you give rotation at angle 60 followed by reflection, you are getting this structure. You can repeat it 2 times. So you are getting result of C3 1 times, and you can repeat it for 6 times. Then you are getting result of identity. And if you go for 3 times, just 3 times rotation about is 6 axis. So you are getting same result by I operation, point of inversion I. So you can say that S6 raised to 3 is equal to point of inversion I. And S6 raised to 6, of course it is, you can say, is equal to E. Now see, this is a ferrocene structure. It is called eclipse ferrocene. So central axis is C5. You can rotate the molecule about C5 axis and followed by taking its reflection. This is a stagger geometry, where both the axes are also there. First you give the rotation and then you can carry out reflection. Same things is there similar to ethane. In the case of eclipse ethane and stagger ethane, where you can have a S3 axis, but here in the case of ferrocene, you can have a S5 axis. That is only different. Otherwise, the rest of the things are same. So this is called stagger ferrocene, where carbon number 1 and 1 dash are away from each other. This is 1 and 1 dash are at 80, and 1 and 1 dash are close to each other. At that time, this is called eclipse structure. Fa is in the center. The angle of rotation is it is a C5 axis. 360 circle is divided into 5 parts, and therefore angle of rotation is 72. If you give it rotation about this C5 axis, then 1 is coming to here, 2 is coming to position of 3, 3 is coming to position of 4 in this way. Similarly, A is come to position of B, B is come to position of C in this way. And then you can go for reflection. So blue color hydrogens are reflected on back side, and where back side जो है yellow color, that is reflected on front side. So this is called one time S5. You can go for second time S5, then you are getting this structure. Third time, this one. Fourth time, fifth time, and this is sixth time. So you are getting original structure. Sorry, you are not getting original structure after 6 time, because S3 3 time करके originally मिल रहा है. S3 S2 6 give you original. तो यहाँ पे भी S5 S2 कितना आएगा? आप कितना आएगा?
5.
नहीं 5 नहीं आएगा. इथिन में कितने कार्बन थे? 3 थे. एक्सिस ऑफ रोटेशन C3 थी. C3 रेस टू 3 इज इक्वल टू, ऐसे एक रूल्स फाइंड आउट किया था. C3 रेस टू 3 इज इक्वल टू S6 raised to 6, S3 raised to 6 is equal to E. So this is we have already checked in the case of eclipse ethane. So look at here, this one. S6 raised to 6, or you can say S3 raised to 6 is equal to E. C3 raised to 3, or you can say S6 raised to 6. S3 raised to 6. Look at here, S3 raised to 6, or you can say C3 raised to 3. तो इस केस में आपकी S5 एक्सिस है, तो S5 रेस टू कितना आएगा? 10 आएगा. Yes, 10 will give you equivalent structure, or you can say C5 raised to 5 is equal to E. So in this case, S5 raised to, you can go for 10 times rotation. 7, 8, 9 and 10 times. 10 times rotation give you structure E, or you can say see 5 raised to 5 is equal to E. So this is about alternate rotation axis. Okay, so up to here, this is we have covered in different type of symmetry elements, its introductory part and how it is applied. See, suppose if you want to go for, say this is your molecule. So I will tell you to carry out this process. What is its result? C2x into sigma xy. This type of question are many times asked in the net exam. ऑलरेडी ये क्वेश्चंस एक दो बार पूछा गया है नेट एग्जाम में. तो अगर ये प्रोसेस करना है C2x is followed by sigma xy, तो ये कैसे करोगे प्रोसेस? तो इसके लिए आपको सी for any molecule you can just assume 3 Cartesian coordinate plus x and minus x plus y and minus y, and this z is on our side and minus z is on back side. So coordinate of this one is x, y, z. Okay. Now suppose if you are applying sigma x, y, or you can go for C2x first. What is result of C2x? आपको एक्सिस लेना है 180 पे रोटेशन देना है, बट किस में से एक्सिस पास होगी? x में से. तो x कंपोनेंट चेंज होगा या नहीं होगा?
X सेम रहेगा.
x सेम रहेगा. Yes, and what is position of y? New position of y?
Minus Y.
Yes, and what is position of z?
Minus Z.
Yes, so your result become x remains as it is, minus y and minus z. Good. Now you can go for, see, applying plane. Plane is always passing through two axes. So you can go for sigma xy plane. That means plane which is passing through x and y axis. X and y वाला यहाँ पे x and y में से plane pass होगा. तो दूसरी दो एक्सिस है उनकी मिरर इमेज मिलेगी आपको. x and y कंपोनेंट जो इन दी प्लेन है वो एज इट इज रहेगा, वो अपनी पोजीशन चेंज नहीं करेंगे. माइनस z का क्या होगा?
प्लस Z हो जाएगा.
यस, ये आपको डायरेक्ट चाहिए इसमें से. सो व्हाट यू कैन डू, एक्स वाई जेड में से डायरेक्ट x माइनस वाई माइनस जेड चाहिए. एक ही कंपोनेंट चेंज करना है माइनस वाई, बाकी दो एज इट इज रखना है.
X Z is called X and Z plane.
Yes, so you can go for sigma x z plane. अगर दो कंपोनेंट अनचेंज रखना है so you go for plane, and दो चेंज करना है तो you go for axis. तो यहाँ definitely x z plane लगे, so you will get this one. So its answer become sigma x z. This type of questions are asked 2 or 3 times in previous year net examinations in the 4 marks. So see, this is a very important how to carry out two symmetry process at a time. Now see, in the next lecture we are going to discuss very important topic of this chapter, that is called molecular point group. How to decide molecular point group. This is very important topic, and that we are going to conduct in next lecture. Thank you very much.
Sir, previous classes की